In this video, I'm going to design a breakout board for a PIC32 in a dip socket. I'm going to start out by making a custom library in Eagle and then doing the schematic for the design you see here. And in a follow-up video, I will do the board layout and generate the Gerber files. So I'll start by going into Eagle. This is version 8.1. And the first thing we're going to do is make a new project in the default folder. And in that project, I'm going to add a new schematic. And I'll immediately save it. I've noticed some bugs where things crash when you save, so save early and save often. Now when we look in this schematic, some of these parts already exist. The resistors, capacitors, LEDs already exist. Other parts like the through-hole connectors that are breadboard spacing are in the SparkFun library, so we'll want to copy those over. The PIC does not exist, the oscillator does not exist, the regulator, the slide switch does not exist, the USB does exist, but it does not have the ID pins, so we'll have to edit that. So let's start by making a library for all the components that will be on this board and copy all the parts in. We'll temporarily minimize the schematic and inside of my project make a new library. Now we can keep the library open while looking in the control panel for parts that already exist and just copy them in. So the first thing I'll do is find all the tags for our voltages. So in the supply 1 library, we've got a 3-volt tag, a 5-volt tag, and a ground tag. Those are all the voltages that exist on this board. While we're here, we'll look at the voltage regulator library, which happens to have the package, which is the footprint of a TO92. That's what our voltage regulator uses. So I'll copy that while we're here. You can also go to the microchip library and get the footprint for the PIC32. That's a DIP24. Sorry, actually it's a DIP28. We see there's two versions of a DIP28, one that's really wide and one that's thin. Ours is the thin one. We also need resistors and capacitors. We'll go to the resistor library. And I'll just take all of the US resistors, all of the non-polarized capacitors, and all of the polarized capacitors. Now the connector for the PIC kit and the connector to the side of the boards, those are really just holes big enough for header pins at 0.1 inch spacing. Those don't really exist in a default Eagle library, so we're going to go to SparkFun's shared library, download and install that, and copy parts out of there that we like. So the SparkFun Eagle libraries, just going to grab the entire zip file. I'm going to rename to remove the dash master at the end. That's something that GitHub does. And if we go to our Eagle folder, there's an a library folder, and we'll paste in here. So now there's a series of SparkFun libraries. The components I want to grab first are those connectors. So in the connectors library, they call them con. So for instance, con 01, a single access point gives us a single hole, and that hole is big enough for a header pin. Con 2, they have a bunch of different styles of these holes. So for instance, lock means they're slightly wider than 0.1 inches, so when you stick the pins in, the pins don't fall out. Sometimes they add a silkscreen around it for a specific component. The one that we really care about here are just the 1x0 whatever. So the PIC kit has 5 holes in a row. So I don't really care about this part, the symbol. I really just want the package. So I'm going to go in the packages and grab the 1x05. We also want the, I'm going to take the 1x03 because we can turn the, we can get the switch out of this one and we can get the oscillator. And the 1x08, that's how we'll break out the pins that we're not using to go into the shield on top of our board. The 1x08 I do want the symbol for, so I'll go grab con 08 for that. What else might we need? So we have the capacitor, we have the oscillator. We'll have to make the symbol for the PIC. We've got these. We'll have to make a symbol for the switch. We've got all of these. We'll have to make the symbol for the regulator and the slide switch. We'll also have to make the footprint for the slide switch. And then we'll edit. We still need to grab the USB. So we'll go grab the USB from SparkFun. And SparkFun happens to be in a retired library. So if we go to SparkFun retired and find the USBs that they have, it's this one. It's the USB MB-H. It's a through-hole mini B connector, and the only thing that exists here is that they do have all 5 holes, including the ID pin, but they didn't add the ID to the symbol, so we'll edit that symbol. So I grab this entire USB part. So let's start there. Here's the USB component. The one that we're going to be using is the MB-H. So let's take a look at that first, maybe. USB MB-H. And I'll do an info on all the pins just to see if the pins exist. So there's bus, there's D minus, D plus, ID, and if I can get in the middle of the circle, ground. So those are the 5 important pins. I've also got 2 through holes to solder in for mechanical stability. And if we look at the USB symbol, take a look at the pins that they put here, D plus, D minus, B bus, and ground. I want to add one more that is ID, so I'm just going to move the name up. Maybe I'll copy one of these pins and then use the name tool to change its name to ID. Now we have to edit the device so that it knows to link ID. So on MB-H, go back to connect. See now there's a pin ID, which we can attach to pad ID. So our USB connector is done. Which one should we do next? Let's do the voltage regulator as an example of how to make a symbol from scratch. So we'll go to a new symbol, MCP1702. It has 3 pins, and a voltage regulator typically looks like inputs on the left, outputs on the right, and ground towards the bottom. And we should double check what the pin's order is. So pin 1 is ground, pin 2 is V in, and pin 3 is V out. So I'll use the name tool. And I like to have the ins on the left here, but the in is pin 2, so I'll call it pin 2.VIN. 1 happens to be ground, and 3 is V out. And I'll create the tags so that Eagle can automatically name it for us, and a value. Draw a box around it. Now we'll go make the device to link up with the TO92 package. So 1 will go to 1, 2 to go to 2, 3 to go to 3. Okay, now we've got a voltage regulator. So we've done the USB, we've done the regulator, we have everything for power except for the slide switch. So let's cover how to do the slide switch now. Here's the slide switch that we're going to solder into the board. We can see it's got 5 pins. The outermost ones are there for mechanical stability, and the 3 in the middle are the electrical connection. And if we look at the drawing, the PDF, they're going to show us this recommended hole layout. So those are the size holes that we need to put in our footprint so that those pins will fit in and we can solder them. The way electrically it works is we're going to apply a voltage to the middle pin, and when the switch is on the left side, it's connecting the middle to the left, and when the switch is pushed to the right, the middle is connected to the right. So we'll have a V out come out of the right side, so when the switch is in the left position, the voltage we're applying here gets connected to that, but that won't go anywhere. And when it's pushed this way, it'll connect to the voltage regulator and power up our circuit. We don't want to connect this leftmost pin to ground. We don't want to connect it to anything, because if this is 5 volts coming from USB and you flipped it to the left, that would touch 5 to ground and short. So really that's just not going to go anywhere. And our outermost pins, which are for mechanical stability, they don't go anywhere either. So first we have to make a symbol for this thing. I'm going to call it slide. So there are 3 electrical connections. Maybe I'll do 1, 2, and 3. And the names aren't super important here, so I'm going to call it pin 1, pin 2, and pin 3, just in order. And I'll try to draw some kind of box to represent the sliding part of the switch. So I'm going to hold Command on my Mac or Alt on Windows to try to draw in a control. What's option? So I'm going to draw this little box here that represents like the slider that gets pushed back and forth. I don't know, some kind of indication that this is a switch. It doesn't matter. We'll add our name tag and a value tag and draw a big box. So that's enough for the symbol. Now we have to do the more important thing, which is the footprint. Because if we don't get these holes in the right position, then our part will not be able to be soldered in. So the first thing to notice on the PDF is that these numbers are in millimeters. So the grid is by default in inches. So I'm going to switch it to millimeters. Oh, not millimeter. And we'll do like a 2 millimeter grid. And if I hold option 0.5 millimeter. And so these pins, they want a 1 millimeter diameter hole for the outer ones and 0.8 for the inners, and then 2 millimeter spacing. I made 2 millimeter grid, so we're just going to put them on the grid. We're going to add these, they call them pads. That's a solderable hole. We're not going to use hole because that's not solderable. We want to solder all 5 pins, so we're going to use pad. And the big one on the left, let's make round, and it has to be a 1mm drill. It's going to be here, and the rightmost is there. And then the electrical connections are 0.8, and there's 3 of those. And we don't have to name the outermost ones, they don't really matter, but we need these inner ones to be 1, 2, and 3 to line up with our symbol. Technically, that's all we need to do, but it would be very nice if we drew an outline around this thing to remind ourselves when we're doing the layout of how big the switch is. So here we can see that the actual size of the switch is 8.6 millimeters long and 4.3 wide, and then there's a switch coming out the side, obviously. So let's draw those guys in. I'm going to use the line tool on layer T21. That's the silkscreen layer. And the width of the line, I don't know, just pick one of these and see how wide it is. That seems like it's wide enough to see. And I've just randomly drawn the position, and now I'll use the info tool to actually set the size. And so it was 8.6 wide. So we want it to go from 4.3 to minus 4.3 and 4.3 deep. So that would be 2.15 by 2.15. That looks about right. The switch doesn't quite go out as far as the outside pins. You can kind of see there. Then the switch pops out one side, and it's a 3 by 2 millimeter. That's not super important. We'll probably have that hang off the side of the board, so I'll just draw it kind of randomly. There, that's the switch. Go back to inches, the 0.1 inch spacing, 0.0125 or something. A place for the name to appear, and a place for the value. These we can always move around later after we smash the part, so we just need to put them somewhere. And finally make the device. So 1 goes to 1, 2 to 2, 3 to 3. Okay, so now I think we have all of the power components. We've got our USB connector, slide switch, capacitors, grounds, power tags, LED, resistor. Next up, now let's do these push buttons. Now the push buttons we have a 0.1 inch spacing, but they're 0.2 apart. So my idea here is first we'll make the symbol for a push button, which just has 2 pins. We'll call them 1 and 2. And we can draw this however we want to describe a switch. I will continue these like this and draw the plunger to make it look like a switch. We'll do a aim value, draw the big box. Actually, in this case, we don't need the box. We kind of know that's a switch. Now what I want to do is make a package that has 0.2 inch spacing with holes that fit header pins, because that's roughly how big those pins are. So I'm going to go into the 1 by 03, and because I like the size of those holes and the positions, I'm just going to copy the whole thing. So I'm going to go into group, select everything, and then copy, and holding command, copy all these things. So while it's now in my buffer, I can go into the package editor and make something else called PB. And I'm going to paste that guy back in. Now I don't need all this stuff, so I'm going to go through and delete stuff. Get rid of the middle pin. And I don't know why SparkFun puts these squares in here. I want to delete those and move this back to the right spot. And then the switch itself is circular, so I know it's going to take up all that volume. So I'm going to manipulate this silk screen to kind of remind myself of how big it is. You can check the datasheet if you're really worried about it being too big. So that's roughly what it is. And it's a switch, so I'm also going to draw like a little indicator that this is a switch, maybe like this. So that's a switch. And we should probably name the pins 1 and 2, 1, and this is 2. And finally make the push button device. Okay, we're getting there. We've got buttons. Let's do the oscillator. It's very similar. It's got all 3 holes. And it calls one OSC. Not really any specific kind of schematic to draw for an oscillator, so I'm just going to put 3 pins. Give them names. The oscillator, pin 1 is, say, OS1, and it's symmetric, so it doesn't really matter if 3 is also OS2. But the middle pin is definitely ground. So the oscillator is actually just like this one, so I'm just going to copy this again. Could have even used the 1x03, but I want to redraw the silk screen. Just to remind us how big the oscillator is, roughly as big as the holes. And finally, the oscillator device. So 1 to 1, 2 is ground, and 3, 2, 3. Okay, now the header pins connections going to our shield. We could just use the 1x08 connector, but I don't like the silk screen on that. It takes up a lot of space, so I'm going to delete all the silk screen from there. So the 1x08 that I copied, so I want to get rid of all that silk screen. And the fastest way is probably to use the group tool. Move the name and value out of the way first. Go to delete. Group again. Delete. No. Get rid of these little dots in the middle too. Move that back. Okay, so that's good position. Let's go make our con 08. Symbol is con 08. Footprint is my 1x08 with no silkscreen. Okay, that looks good. Let's do the same thing for the 5-pin connector for the PIC kit. I'll just make a whole new symbol for it. 5 pins. Pin 1 is MCLR, pin 2 is VDD, pin 3 is ground, and let's see, pin 4 is DG, DGC. We'll use 1x05. In this case, again, I don't want that silk screen. Here's a trick we could do. We could actually turn off the via and the pad layer, and then select everything that I like, and delete. Go back, turn those layers back on. They're still back. Now this over here is pin 1, which is MCLR, and I want to remember that that's where the PIC kit plugs in. So I'm going to draw a polygon in the silkscreen layer that looks like a triangle, so I remember that the triangles should line up. Oops. And finally, PIC32 device. Okay, we have oscillator, we have PIC kit, we have all the power stuff, buttons. Last thing to do is the PIC. That's the big one. I'm try to fill up the screen a little. So this is specifically the PIC32 MX250F128B, and this probably isn't the best way to design symbol for this because I'm specifically going to be making it for the dip package here. So we won't be able to reuse this symbol for non-dip PICs, but that's okay, that's what this project is using. I'm just going to copy this. Be better to copy from the PDF to make sure we don't mess it up, but I'm pretty sure this is the right layout. 7, 6, 5. 1, 2, 3, 14 pins. One, two, three, 4. 4. Trying to keep things symmetric so it looks nice. Now we have to give a name and value if I forget. So the best convention here is to start with pin number 1 point and then the function MCLR 2 point pin A0 3 point A1 4 point PGD is also B0 5 point PGC, which happens to also be B1 point 2 point B3 point BSS. Looks like A2 is also oscillator 1, so I'm going to note that here. I didn't on that one I'm copying from. So pin 9 is os1 slash A2, and pin 10 is os2 slash A3. 11 is B4, which is where we happen to be putting our user switch. So I'll try to remember that here. 12 is A4, which also happens to be our LED. 13 is one of the power pins. 14 is USB ID. USB 5. It's kind of overlapping, so I'm just going to move them a little. Okay, so those are all the pins on the PIC32. A quick box around it. Okay, make the device. And because I use that naming convention 1, 2, 3, I've got 1, 2, 3, so I can just go all the way connect. Okay, so here's my library. We've got resistors and capacitors. We've got the PIC. We've got the regulator, the oscillator, push buttons, USB slide switch, some power tags. I think those are all the components I'm going to need to design the circuit. I'll end this video right here and immediately start back up by doing the layout.